Okay, something you'll come across in your homework this week is least common multiple, which is also sometimes shortened as LCM. So it's going to ask you to find the least common multiple of 2 or sometimes maybe 3 or 4 numbers. So first of all, we're going to see what is a multiple. Multiples are numbers, are just what you get when you start multiply them by 1, then 2, then 3, then 4. It's the same as counting by that same number. So the multiples of 2 would be 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and so on. So we end up just counting by 2's. 2, 4, 6, 8, 10, 12, etc. Okay, so now let's try to find the multiples of 3. We do 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and you can see we just end up counting by 3's. And those are the multiples of 2, and these are the multiples of 3, and they go on forever. You can even find the multiples of something like 14. 14 times 2 would be 28, then 14 times 3 would be 42, 14 times 4 would be 56, and so on. We're just counting by 14s. So that's how you find the multiples of numbers. I'm going to take away these 14s for a minute and just focus on 2 and 3. So if your problem in your book said find the least common multiple of 2 and 3, we'd take a look at this list and we'd try to find multiples that are common to both, that are in both of these lists. 12 is in both of these lists, but it isn't the smallest one. We're looking for the least common multiple. So we have to go back closer to the start. And we can see that 6 and 6 are in both lists. The only other multiple that is smaller than 6 is a 4, but it is not a multiple of 3, so we can't use it. The least common multiple of 2 and 3 would be 6. So let's try to find the least common multiple of 2 different numbers. We're going to go ahead and find the least common multiple of 4 and 10. So we'll start by saying 4, we're going to start by counting by 4s, or finding the multiple of 4. 4, 8, 12, that's 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, etc. We're just counting by 4s to find the multiples of 4. The multiples of 10 are counting by 10s, 10, 20, 30, 40, etc. Now, if we want to find the least common multiple of 4 and 10, we have to look at the lists and see what is common to both of them. So if we look at the list, we can see there's 20 here and there's a 20 here. That is the smallest number that both 4 and 10 can be divided into evenly. So the least common multiple of 4 and 10 equals 20. Now, they're going to ask you in your homework to find the least common multiple of some, like maybe three numbers. Let's say 12, 20, and 15. It would take a long time to write out all the multiples of 12, write all the multiples of 20, and write all the multiples of 15, and then look at each list and find the common one that is the smallest, or the least common multiple. There is a different way to do it. That involves factor trees. We've been working with factor trees, and we know that what we do when we do a factor tree is we're looking to get to all prime numbers so that we can find the product of prime numbers that equal 12. So we're going to say 4 times 3. You could have said 2 times 6. It'll all end up the same. So you just pick 2 numbers that, you know how to do this. You do 2 numbers that multiplied together equal 12. 2 numbers multiplied together that equal 4, and 3 is already a prime number, so we circle it. When we get to the prime numbers, we rewrite 12 as a product, which means multiplication, of prime numbers. 2 times 2 times 3 equals 12, and these are all prime. We'll do that for 20. We'll say that 20 equals 4 times 5. 5 is prime, so we can circle it. We have to continue with 4 until we get to the 2's. These are all prime numbers. 20, written as a product of primes, is 2 times 2 times 5. 2 times 2 is 4, times 5 is 20. 15 is fairly easy because 3 times 5 equals 15, and they're already primes, so we stop right there. Now, how do we use these product of primes to find the least common multiple of these three numbers? Well, here's what we do. We look at these lists, and we start with the number that is the smallest. And I see in these lists that there's 2. Then, once we know that there's a 2, we have to look at each of the lists and find out how many 2's there are. We have to find the greatest number of 2's. This has 2 2's, this has 2 2's, and this has none. So the greatest number of 2's is 2. So we write 2 times 2. If this had 3 2's, we would write 2 times 2 times 2, because 3 would be the greatest number. Now we find that there's 3. What's the greatest number of 3's in this list? There's 1 3 here and 1 3 here. So the greatest number is 3. There are no 3's in this list of product of primes, but that's okay. We just want the greatest number. Then the only other number that we have than any of these lists is the 5. And there's only 1 5 here and 1 5 here. So 1 is the greatest one. So that right here gives us a clue to what our least common multiple of 12, 20, and 15 is. We can multiply that out, and we can see that 4 times 3 is 12, times 5 is 60. So 60 is the least common multiple of 12, 20, and 15. So counting this out, it would go 12, 24, 36, 48, 60. So it's a multiple of 12. This would be 20, 30, 40, 60. That's a multiple of 20. And this would go 15, 30, 45, 60. 60 is the smallest number that 12, 20, and 15 all go into. So that's how you use a factor tree to find the greatest common factor of some numbers. I want to do that one more time with a group of 3 that is a little trickier, just so you can see. We'll do 24 and 14 and 12. No, not 12. We'll do 18. Okay. If it asks you to find the least common multiple of those 3 numbers, start with a factor tree. We're going to do 4 times 6. Neither one of those are prime, so we will continue. Those are prime, we can circle them. And these are prime, so we can circle them. So 24 listed as a product of primes is 2 times 2 times 2 times 3. Those are all prime numbers, and multiplied together, they equal 24. 14 is fairly easy. It's 2 times 7. Once we get here, we can stop because they're both prime. And 18 we'll do 3 times 6. 3 is prime, we can circle it. 6 is 2 times 3. Those are prime, so we can stop, and we can write 2 times 3 times 3. Now, we look at all 3 of these product of primes. First, we look and see. The first number we see is a 2. There are 3 2's here, 1 here, and 1 here. The greatest number of 3's in either of these is, the greatest number of 2's in either of these is this one, and it has 3 2's. So we need to write all 3 of those 2's down. Next, we see a 3. There's 1 3 here, none here, and 2 3's here. 2 is the greatest number of 3's that one of these terms has. So we're going to write down 2 3's. We did the 2's, we did the 3's. There's one more number we need to look at. That's a 7. There's only 1 7, so we just write it here. So now we can use this to figure out what the greatest common, the least common multiple of these 3 numbers are by multiplying. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. 24 times 3, we can write it off over to the side if we need to, is 72. 72 times 7 is 50. 504. So the least common multiple of 24, 14, and 18 is 504. That's the smallest number that each of these go into evenly. So that's how you find the least common multiple using factor trees.